Hey y'all, we're going to look at solving systems of equations today. So, let's see what we got. Okay. We're going to do substitution and elimination. So think back to like math 1, but with a little flair. Okay. So first off, we're going to determine if the ordered pair is a solution or not. So what do we need to be a solution? The ordered pair needs to work in both equations. Okay, so let's go ahead and start. We'll start with the first one. 4 times our x is -1 and our y is -5. So 4 times -1 minus -5 is equal to 1. Let's see, -4 plus 5, that does equal 1, so that verifies. But am I done yet? Nope. Gotta try it in the second equation. Okay, so 6 times -1 plus -5 is equal to -6. So -6 plus -5 is -6. This is not true. So -1, 5 is not a solution. It's only a solution to one equation, and I need it for both. So if I have a system of equations that looks something like this, this point, -1, 5, would only be the solution to one equation. Okay? So let's try the second one. Let's do our top equation. So 4 times -1/2 minus -3. Does that equal 1? So -2 plus 3, that equals 1. That verifies. Second equation, 6 times -1/2, minus plus -3 is equal to -6. So I get -3 plus -3 equals -6. So that verifies. On a system, that would look like an intersecting point of intersection. Okay? Next, what kind of solution do each of these linear graphs have? Well, if they're right on top of each other, that would be infinite solutions. So they're all ordered pairs on that line work. When they never intersect, that's no solution. And when they intersect one time, that would be one solution. We're going to look at some other graphs today that are not linear. So like if a quadratic and a line intersect, how many times could they intersect? Well, they could intersect once, they could intersect twice, or they could intersect no times. Okay, so we'll look at some other different types of curves as well. So let's go ahead and get started with the substitution example. So if I have x squared plus 4x minus y is equal to 7, and 2x minus y is equal to -1, I'm going to look at the top one and be like, that is a quadratic, and the bottom is some kind of line. So just like before, we could intersect one time, 2 times. So I could have a parabola, have it intersect 2 times. I could have a parabola, have it intersect 1 time, have a parabola, and have it intersect no time. So we'll see what happens. So first, we need to solve one equation for y. So isolate one variable. So I'm going to go ahead and isolate y. So I get 2x plus 1 is equal to y. Now I can take this 2x plus 1 and sub it into the other equation. So substituted y into the other equation. So I get x squared plus 4x minus 2x plus 1 is equal to y. Let's go ahead and simplify. Oops, I don't want to distribute that. It's equal to 7. That's better. Okay, distribute the negative. So I get x squared plus 4x minus 2x minus 2 is equal to 7. So x squared plus 2x minus 2 is equal to 7. This is a quadratic, so I'm going to go ahead and subtract 7 to both sides, giving me x squared plus 2x minus 9 is equal to 0. Go ahead and big X this, so negative 9 on the top and 2 on the bottom, but multiplies to 9 and gives me, I have a mistake. I see my mistake. It's right here. That's a minus 1, which gives me a minus 8. So it multiplies to negative 8 and adds to give me 2. So that would be negative 2 and 4. So my factored form would be x plus 4 times x minus 2 is equal to 0. Using zero product property, I get x is equal to negative 4 and x can equal 2. So I'm not done yet. I have to plug in to find a point of intersection. So when x is equal to negative 4, I need to figure out what my y is. If you go back, I could use any of these equations, but I see that I've already rewritten the bottom equation to be y equals, so I'm going to use that. So y is equal to 2 times negative 4 plus 1. So y is equal to negative 7. So my point of intersection is negative 4, comma, negative 7. Am I done? Nope. Now I got to do the other one. Okay, so we're going to look at x is equal to 2. So y is equal to 2 times 2 plus 1. So y is equal to 5. So my other point of intersection, it looks like I have 2, is 2, comma 5. Okay, so these are both answers. So I have a graph that looks more like that. Next. So this one is a cubic. So the bottom one's a cubic and a line. So I'm going to have something like this. And then I could have a line that either goes through 3 points, a line that goes through at 2 points, or a line that goes through at 1 point. Can I have 0 points? No, because at some point it's going to have to cross these arms here. Okay. So again, I'm going to take the top equation and isolate y. So y is equal to 2 minus 3x. And then we'll substitute into the bottom. So x cubed minus 2 plus 2 minus 3x is equal to 0. So I get x cubed minus 3x, and the 2's cancel, giving me 0. Everybody's favorite, greatest common factor. I see I have an x in common, so I'm going to take out the x, and I get x squared minus 3 is equal to 0. So using zero product property, I get x is equal to 0, or x squared can equal to 3, which means that when I square root these, I get plus or minus root 3. So again, we are not done. We're going to have to solve for the y's. So I'm going to use this equation that I rewrote since it's already solved for y. So x is equal to 0. Y is equal to 2 minus 3 times 0. So y is equal to 2. So I get a point of intersection at 0, comma 2. We're going to go for another one. Let's see. X is equal to root 3. So y is equal to 2 minus 3 times root 3. That can't simplify anymore, so I get root 3, comma 2 minus 3 root 3. And then lastly, let's do x is equal to negative root 3. So almost the same. 2 times, negative times a negative is going to give me a positive. So plus 3 root 3. So I get negative root 3, comma 2 plus 3 root 3. And those are my points of intersection. Looks like I have a line that goes through 3 times like that. Okay. Okay. Lastly, we're going to look at elimination. So I'm going to, when I add up my variables, I want to eliminate one. So I'm going to multiply the top and the bottom. You have lots of options, but I'm going to multiply by 2 and negative 5, giving me 10x plus 6y is equal to 18. And on the bottom I get negative 10 plus 20y is equal to 52. No, 70. Just kidding. Negative 70. Okay. So when I add these together, the 10s cancel, giving me 26y is equal to negative 52. Divide by 26. I get y is equal to negative 2. So now I got to find my x. So either equation, I'll just use the top one. And then I wrote the bottom one. So 5x plus 3 times negative 2 is equal to 9. So 5x minus 6 is equal to 9. 5x add 6 is equal to 15. Divide by 5. So x is equal to 3. So my point of intersection is 3, negative 2. Last one. Okay, so by elimination, looks like we have a 4 on the top, or a 4 on the bottom, so I'm going to multiply by negative 2 to give myself an opposite sign. So negative 4x plus 2y is equal to negative 2. So I get 4x minus 2y is equal to 2. When I add these together, I get 0, 0, and 0. So 0 is equal to 0. That looks like a theta. So what happens in this situation is I get infinite solutions. Okay, so what would happen? What kind of solutions do I get when I eliminate to get like 8 equals 0? Okay, so when you eliminate your variable and these don't make sense, 8 does not equal 0, your answer is no solution. And that is it.